Hello and welcome to tutorial 196, and in this tutorial we're going to be looking at scope in methods. To demonstrate this, what I'm going to do is convert two functions into methods. The two functions being the xAverage function, which is a series function, and the other one being average, which is a simple function. I'm actually going to do two videos because this is actually quite a lot of material. In the first video, we're going to convert the xAverage function. This is not necessarily a good thing to do because some things are better in functions, some things are better in methods, but it does enable us to discuss method scope. So in the first method that converts the xAverage, I'm going to use a method that references variables declared at the study level. In the second, what I'm going to do is create a method that only references variables passed in through a parameter list and a locally declared variable. In other words, a variable declared in the method, not at study level. And it is this second way that is seen as better programming practice, although I think the first is perfectly valid in a number of situations. So let's have a look. I've got the exponential moving average applied to the chart using the function. So here we have what I've called demonstration 1, and I'm doing two things. First of all, I'm calculating the xAverage and plotting it as value using plot2, but I'm also calculating it where I'm putting a restriction on the calculation. I'm only starting it from bar 200, and this just leads us to something which is important to note about series functions, and that is that they update their value on every bar, even if the function call is placed in a conditional structure, which may not be true on every single bar. In this case, we've got it true after we've counted to 200, because the series function automatically stores its own previous value and executes on every bar. Let's have a look at the chart, and what I've got, we'll see here we've got plot 2, and then we'll see at the bar 200 we start getting plot 1, and you'll see that the values are identical. And that is because looking at the program you might think, oh well, it's only starting bar 200 to calculate. It's not actually the case because this is a series function. Anyway, that's just by the by, because what we're really doing is looking at a method to replicate the function. So in deciding how to do the calculation, what we can do is open the function, which is right click, open the function. And if you go into the function, you'll see we've got the calculation here. Essentially, you can just look at that, just take a mental photograph of that, because we're now going to go to create the first method, which I've called exponAv. So I'm just going to go to the top of the program where I've put that, and you'll see it here. Very, very simple. We're using method void, and then we're putting in two values, the price and a length. And then we're using a variable xAv. Now that variable is declared at study level, as you'll see here. So we're not returning anything, returning is void, but what we're doing is using this value at study level. And because it's at study level, we can actually use the previous value. So if I were to go back to where we're calling that, and I'm just going to uncomment plot 3, and you can't see it because it's hidden below the others, but what you will see if you compare the values like I'm doing here, and you'll see that the value that I'm calculating using this method is identical to the value calculated by the function. Okay, so that is exponAv, but what about if I wanted to create a method to keep the scope of the variable within the method? And so what we're going to do that using exponAv2. Let's just go and have a look at that and see how that differs. Okay, so you'll see now that we are returning something. We're returning a double, and we are defining a variable inside the method where the scope of that variable is just inside the method. Now the other thing, because we're using a variable that's defined just inside the method, it has no record of what its value was on a previous bar. So what we need to do is, by way of parameters, we need to input the price, the length, and what I'm calling the xAv last. In other words, the value of the exponential average, the previous bar. When we do that and return the value, then go down to where we're plotting the value and going to verify that. And again, if we just move our mouse, in fact, let me just change the studies. So just going to changing the thickness of the plots, and you'll see now that the latest plot calculating this other value using this method where the scope of the variable is inside the method is giving us exactly the same value again. But what if we were to take this method and only start calling it from, say, bar 150? Well, that's most likely going to give us something different again. So I'm going to uncomment plot 5 and go back to the chart, and you'll see here that what's actually happening is that from that bar starts to be calculated and eventually reaches the same value as the other calculation. Let's just move on a little bit further and just double check that. So it gradually converges to become the same value because we started it from a later bar. So there you could see, for example, a good reason why you might use the function as opposed to using a method to calculate this value. Now, one other thing I just wanted to demonstrate is x_average2. Now, we define that, if you recall, with a local scope in the method here. But what we could do, not necessarily a good idea, but what we could do is have the same name defined with the scope of the program. Now, the way the program is going to treat these two variables is completely different. So we're setting the value of that variable to be initially 0 in variables, and we're not doing anything to it in the program. We're defining another variable that happens to have the same name here, which we're using. But if I were to uncomment this to say print the value of x_average2 and verify that, what you'll see is that value is coming to 0, even though the value used in my method is actually calculating to be something different, which is just a facet of scope. Okay, so that's a little bit of information about the exponential moving average. In the second video, what we're going to do is look at converting average and some of the issues regarding doing that. So I hope you find this useful. If you're not on the Markplex email list, then please go to markplex.com, markplex.com, and also please subscribe wherever you're watching this video. Thank you.